Born in Germany and living in the Netherlands already since 2006, currently living in Nijmegen, working for the Radboud University. And yeah, as already mentioned, I want to tell you about IRMA and verifiable credentials and the subtitle, How to Authenticate in a Decentralized, Privacy-Friendly and More Reliable Manner Across Systems. Yeah. So first, I want to talk about one of the current issues with identity management. That is, it's centralized traditionally. So I give one example. This is one model, but there are also other models. But for now, let's keep it also simple. And yeah, this is me. I want to authenticate or request a service at my health insurer, VGZ, which is the service provider in this case. And so I'm requesting a service, and in order to be able to access the service, I need to authenticate. And how does this work in the Netherlands? Usually, the service provider asks DigiD, which is the identity provider, one of the identity providers in the Netherlands owned by the government, to authenticate to certain services. And so the service provider asks DigiD, is this really Daniel? And then I need to authenticate at DigiD, and DigiD then gives the OK to the service provider that I'm indeed Daniel. So in case of extreme events, we clearly see that this central party, the identity provider DigiD, is one of the bottlenecks. Because we have seen in the past that there were denial of service attacks also on DigiD, and it was not available for some time, and also quality of service issues. So, researchers and industry are working on solutions worldwide. One of them is IRMA, standing for I Reveal My Attributes, developed at Radboud University some years ago, and it advertises itself on their website with having the digital passport on your phone. Currently, it's maintained by SEDN, which is also responsible for maintaining the NL domain. And yeah, one of the interesting things about IRMA is that it's completely open source, so you can look up all the source code on GitHub. And it implements partly the IBM's IDMX specification. That IDMX stands for Identity Mixer, and it's a cryptographic protocol suite for privacy-preserving authentication. If you want to learn more about the implementation of IDMX within IRMA, then I invite you to go to the talk in the evening of Maya and Zietze, also sitting here, which will tell you at 9 p.m. today in the Abacus about IRMA's IDMX implementation, the crypto behind selective unlinkable attribute disclosure. So how does IRMA then work, and also similar systems? We have two independent processes. First, the issuance, and second, the disclosure. First, during issuance, for instance, the government in the Netherlands can issue me a personal data credential, which consists of my name, my birth date, and, for instance, also my address. So this credential will then, after I authenticate to the government with DigiD, will be transferred to my phone, and me, as the owner of the credential, is then can disclose this credential whenever I want. A credential consists of certain properties. So first, it's bound to the phone via some cryptographic tricks. And it contains metadata from which issuer it's issued, for instance, the Dutch government, also when it was issued and when the credential expires. Also, logically, it contains then attributes, and most importantly, also the issuer's signature, because the issuer signs all attributes such that another party, the verifier, can verify that the credential and the containing attributes are indeed valid and issued by that issuer. So if I now want to use those credentials, I can go to a service provider, and the service provider requests then that I need to prove something. For instance, that I'm above 18 years old. So where do I need to want to disclose such information? For instance, when I want to buy some liquor at the Gal en Gal. So the Gal en Gal is in this case a service provider, and he wants to know that I'm indeed above 18 years old. So the trust model in this case is that the Gal en Gal trusts the government that the government issues valid credentials to the rightful citizen. However, during disclosure, the Gal en Gal does not need to talk with the government. So this is privacy preserving in that sense that the government doesn't learn as identity provider when I use the credential in question. So that's one of the advantages of this decentralized identity model. So zooming a bit in, how does a session in IRMA work? First, we go to a website, and I chose now to have an example of verifier. The verifier then starts a session at an IRMA server, which the verifier can run himself. After initiating the session at the IRMA server returns some session information, and based on the session information, the verifier can create and show a QR code to the user. Then the user scans the QR code, so the IRMA app gets information about the session, and subsequently the IRMA app also requests the information which attributes need to be disclosed. And then the user can choose. With an IRMA, it's possible to also make a construction that a user has a choice which attributes to disclose. And then he can select in the app and disclose the attributes. And then in the end, the verifier can look up at the IRMA server if the disclosure was indeed successful and valid. Now, one practical use case I want to refer to, because I'm currently working on it, is Postguard. It's in Postguard we have the goal to make email encryption accessible for everybody, so it's easy to use. We all know the issues, the usability issues with OpenPGP, right? And how we do that is by utilizing identity-based or attribute-based encryption. In this concept, we have a private key generator, which is a trusted third party. So that's also an issue. We'll talk about it in a second. And if Alice wants to encrypt for her Dr. Bob, for instance, she just needs the identity of Bob, for instance, his email address and some attribute related to that he is a doctor, and the public key of the public key generator. And then Alice can encrypt the mail. Then we ship the mail via our well-known SMTP protocol to Bob, but all the payload is encrypted during transport. And Bob can then decrypt by proving his identity via IRMA to the private key generator. And if the private key generator then validates the disclosure, it generates a user secret key that matches the identity with which Alice encrypted, and then Bob can decrypt the email. So this decentralized and user-centric identity systems are also referred to nowadays more often as self-sovereign identity systems. Christopher Allen published an article in 2016 titled The Path to Self-Sovereign Identity, where he also lists 10 different principles such a system should adhere to. Unfortunately, it's also often associated with distributed ledger technology because the bigger parties such as IBM really use it for marketing purposes to sell their distributed ledger technology more. More recently, in Germany, there were some projects called ID Wallet and digital school certificates based on distributed ledger technologies and the principles of self-sovereign identity. But as we've seen, those projects failed at the moment, so they are not online anymore. And I think they will further work on it. But also the Bundeszentrale für Sicherheits- und Informationstechnologie, the BSI, discourages the use of distributed ledger technologies in such decentralized, user-centric identity systems. Also interestingly, recently the European Union announced that there is a European Digital Identity Initiative. There's still a call for proposals. The deadline is on the 17th of August 22, and they asked for the industry and researchers to submit solutions per country, and with the goal to have per country maybe one system deployed in the end, and that those systems are then interoperable. So if I now travel with my credentials to Germany, that I can also use my Dutch credentials in Germany to authenticate and, for example, to prove that I'm above 18 years old. Also, sure, IRMA is also participating in this. So there is also some discussion, especially in Germany, that there are also some drawbacks with self-sovereign identity or decentralized and user-centric identity systems in general. Some of those arguments are nicely written down by Lilith Wettmann. My German friends here will probably hear about her in the last 2 years. So, and she argues that with self-sovereign identity systems, service providers have verified data stored, and those are more valuable for criminals. Also, once you have such an infrastructure deployed, it's also easier to add identification obligations in the future. Also, states often leave it to the market to develop solutions. And then the question is, okay, what's the business model then for those organizations, right? How do they want to earn money with their identity? Do we want that as a society? And citizens are then becoming responsible for maintaining their credentials within their phone. So what happens if someone commits fraud with them? Who is liable for this? One of the goals of the European digital identity was to make such platforms interoperable, right? What I said, so you can go from travel from Germany to the Netherlands and then use the credential from one country in another country. So one of the current issues is that there is no standard defined how different identity apps, such as IRMA, It's Me, Schluss, or the American Sovereign, talk to each other, right? How to exchange credentials between systems, such that I can, for instance, have my personal data credential from IRMA stored within my IRMA app, and someone deploys an It's Me server and then can verify my IRMA credentials within an It's Me system. First, the W3C, the World Wide Web Consortium, developed a standard called Verifiable Credentials Data Model, and it became a recommendation version 1.0 in May 2020, I think. And in the meantime, they also updated some minor things, so it became a 1.1 version. So important to see here is that this proposal contains a data model, which is an unambiguous specification defining walls, the interaction between walls, and related concepts, and also providing a syntax, usually in JSON. So I will give a little example in a bit. So if we now look at the walls and information flow of the verifiable credentials data model, we see clearly some similarities with the IRMA system. Right? We have here an issuer that issues credentials. We have a holder or a user that needs to store the credentials within a wallet app on the phone. Then we have a verifier on the right end that requests credentials and verifies them. And on the bottom, we see we have a verifiable data registry that maintains identifiers and schemes. So I didn't talk about this yet, but I will do in a bit. And with an IRMA, we have the similar concepts. So an IRMA scheme is very important because it contains information about the issuer, which credentials an issuer may issue, and also the public keys of the issuers that a verifier needs to be able to verify that the credentials are indeed valid. So the IRMA scheme is distributed via the IRMA scheme manager. So it's hosted on GitHub, and every instance of an IRMA service or the IRMA app regularly pulls the most recent version of the official IRMA scheme, so it stays up to date. However, in the verified credential data model, it works a bit differently. So, for instance, as you can see here, the green row within this example, we see a URL that links to, if dereferenced, contains some information about the issuer, and I think most importantly contains the public key of the issuer, so anyone receiving this credential can verify it. So what I did within my work is developing a metadata server within the IRMA system, such that external parties can request information about the issuer and about the credentials used by offering two distinct endpoints, the issuer and the schema endpoint. So we can conform to the verifiable credential data model. So the prototype I built, to summarize, is providing this metadata server, wrapper within IRMA Go. IRMA Go is a central component with which you can run an IRMA server, but also parts are used within the app to compute verifiable credential compliant messages. Also, I showed that we can exchange verifiable credential compliant messages between different IRMA components. So during my study, I was not able, due to time constraints, to find other parties, for instance, it's me or Sovereign, that want to work together with me to show that we can indeed exchange information between different systems. So the source code is also available on my GitHub. I forked the IRMA Go and the IRMA mobile repositories. And to wrap it up, I think, how's the time? So what I just said, the prototype shows how to compute VC-compliant messages within IRMA. By conforming to the verifiable credential data model, IRMA's interoperability increases. However, one of the most important things to discuss still is that the APIs and the cryptos a system implements can differ in each system, and that's also the biggest challenge. That, yeah, for instance, IRMA utilizes the IBM's IDMX specification to implement some protocols, but other systems can implement other crypto. So how do you make sure each system understands crypto of all the other systems, right? I think that's one of the most complicated things in this whole verifiable credential standard. But I think we have a similar discussion currently about making messenger apps interoperable. I think there we have kind of the similar challenges. So on a more higher level, we can state that with decentral identity management platforms, we can improve the reliability during extreme events because we are not relying on the central identity provider. There are also several decentralized and user-centric products available on the market, as we've seen IRMA, for instance, and Schluss in the Netherlands, and It's Me in Belgium, which is really used heavily there by citizens. The BSI states that it doesn't recommend the use of distributed ledger technology within such systems. We have seen that systems use it for like storing also a scheme, right? So in a decentralized manner, they try to distribute the scheme such that everybody can receive the right information about issuers, for instance, the public keys. And in the end, we have the European Digital Identity Initiative. It gives opportunities to empower citizens to be in control, in sole control of their identity. But as I have shown, there are also some drawbacks that we still need to address. So it's a call to action for everybody here who wants that this goes in the right direction. Because within the European Union, it was also one point was that we have some unique identifier for every citizen within Europe, so such that we can have, can identify everyone, and I think we don't want that as a community here, at least. And that's the end of my talk, and so we still have some time for a Q&A.
So thank you very much. And if there are any questions, please line up at the microphones in the middle of the room. We do have some time if anyone wants to know anything. Okay. First, front microphone, please.
Hi. You mentioned, and it's on the slide, that a distributed ledger is not recommended by the BSI. Could you tell a little bit more about that, about the whys? And
the whys? Yeah, because they argue that the technology is not mature enough and it gives more risk than it benefits an actual system. So I don't have all the details now in mind, but I referenced it. So I asked you then to look up if you really want to know all the details, what they write in their report. So, that's...
Okay, next question.
Hello, and thank you for your talk. Let's assume that every wallet now has those verifiable credentials. We don't have interoperability yet. What would you recommend? How should the wallets then work together?
If we don't have interoperability, you mean?
Let's assume we all implemented this and it's just a standard, and you know that there are still limits. You don't have the interoperability just by implementing the standard. So what if we now have all those verifiable credentials? How should we continue to actually get interoperability?
Yeah, exactly. So to increase the interoperability even further. So I think what we need is some agreement within the community also to think about which kind of crypto we want to support, what is really the good crypto, for instance, right? What IRMA currently implements parts of the identity mixer of IBM, that we kind of standardize this and make it kind of a library, so other systems can just load this library and then have the crypto included in the system already. So I think it needs to go into that direction, that we have some agreement on the good crypto, and then maybe have different libraries that implement this different cryptographic systems, so other decentralized systems can easily implement it or use it, let's say, right?
Okay, next one.
Hello. I would like to remind you that we had a talk about bring your own identity on Friday, which allowed authentication on any server by using one identity provider. And maybe after this talk we can have a little chat how your IRMA project can coincide with our Bring Your Own Identity project. And the designer of Bring Your Own Identity will be here in a while. And maybe that's interesting, because what we did, we created a system that to prevent to have credentials on all those services as Google, Facebook, and so on, to be removed and be delegated to your own identity provider. And because this talk is also very much about identity, maybe there are interesting causes, coincidences, so to speak.
But if
this is not really a question, but maybe I
Well,
want to point out maybe something can be combined with IRMA and bringing your own identity.
But if I understand correctly, you say that you then have your identity stored at one identity provider, but then it's also centralized in a way, right? So that's also risk.
Indeed, what I was thinking of, it's also a problem because when the identity provider goes down, you can't identify anymore. But that's what you solved, and maybe that can be combined.
Yeah. Okay, maybe we can talk later also. Yeah, I'm here.
So apologies if I missed most of your talk, but so I was paying attention to these verifiable claims work attached to the W3C from pretty early because I had somebody dragged me into being involved in the e-payments thing. There was a lot of incompetence there from the beginning, but one of the things that kind of stuck out to me, and apologies again if you've already touched on this, but you really don't want any identity system that is sort of general purpose and relocatable against different things and that reveals attributes of people. So if you go through like the verifiable claims, like their documents, if you go through like their use cases documents, it talks about using, like, for example, to prove you have a job to get a bank account, which, okay, that's fine, but how often do you open a bank account? It's perfectly fine to ask your employer for a letter. Whereas what's much more likely to have, where that feature would get used much more often would be when you're going to apply for a job, because an HR person generally prefers people to already have jobs, and so they'll just filter everybody because that's how bureaucracy sometimes work. And if you go through all of their use cases, like, you can pretty much just flip it on its head and say, how can this be misused? And pretty much all of the attribute use cases can be misused. So my general feeling is, the question, apologies for this not being a question, but the question part of this is, have you looked at Brian Ford's proof of personhood parties? Because in Brian Ford's model, there are no attributes. It's just you have, it's a function that maps a context to unique identity. And so then there's no need for, or then we have no attributes. We just have, in a given context, I have a unique identity, and then I have another one and another identity, and there's no.
So you mean you get the identity from the government, for instance, right? Which has some unique identifier? Or?
In his model, so has this anarchisty thing. Essentially, they want these proof of personhood parties where people produce, but de facto, the proof of personhood parties are a side government. So yes, it's coming from a government, but it's not the government. It's this like anarchisty construct. But you could do it issued by a government too.
So yeah, I don't really understand it correctly yet. You're like, yeah, maybe we'll talk after, yeah.
And time is up, sorry. But he will be available afterwards, I'm sure. And thank you very much for the talk. I think you were the first person who tripled the audience during talking, so please give him a round of applause, which is at least triple to before.